In order to have a better understanding of polynomials, you need to first talk about exponents and how those exponents can be altered using your exponent rules. So with that, there are several different exponent rules. The first one, anything to the power of 0 is 1. So if I have a to the 0, it's 1. If I have 3 to the 0, it's 1. If I have negative 2 to the power of 0, it's 1. Okay, that's one of the easier ones to work with, but it is still an important one. The next one is if you have a same base. Sorry, there are actual names for these. Same base multiplication. If I were to have a to the 4th times a to the 3rd, even though you are multiplying the base part, which is the a, your exponents actually get added. So this is realistically a to the 4 plus 3, which is a to the 7th. If you were to have division, so same base division, so with multiplication, we added. With division, we subtract. So if I have a to the 5th divided by a cubed, I'm realistically going to have a to the 5 minus 3 to give me a to the 2nd. If I have properties of powers, so power to a power, if I were to have a to the 4th cubed, okay, so there's not a same base multiplication going on. It's a power raised to another power. So you're actually going to multiply these. So it'd be a to the power of 4 times 3, so a12. And that goes to the same thing with a quotient. It just kind of depends on what you want to do. The power goes to everything inside those parentheses. That's the biggest thing. Last but not least, negatives. Negatives flip, and that's kind of a tricky concept for most people. So if I have a to the negative 4, this is actually, so you flip this fraction part here. It's realistically a over 1. So this now changes to 1 over a to the 4th. Okay, and the biggest thing is why you need to know that negative exponent. When you simplify anything, a monomial, any type of polynomial in general, you can't have negative exponents. So you have to use that negative property in order to flip it. And this is only dealing with the exponents. So when you're thinking about this and we're simplifying, don't forget that the coefficients in front keep the same properties as they normally would. All right, so enough about the actual properties. Let's get to the heart of the matter. How do I actually simplify when I've got something there? So let's say that I've got 3x to the 4th, y to the 6th, times negative 4x squared, y to the negative 10. All right, so looking at this, the coefficients. Coefficients are the big numbers. They aren't the exponents, remember? So for instance, the 3 here and the negative 4 here. Those are coefficients. Those aren't actually exponents, so they keep their same properties. So 3 times negative 4 is going to give me a negative 12. These are all my variables with their exponents are on the same playing field. They're in the numerator technically. And it's the same base. So I'm going to add at this point. So I have x to the fourth, x squared, so I'm actually going to have x to the power of 6. I'm adding those exponents. With the y's, I've got 6 plus negative 10. That's going to give me a negative 4. So right now, I've got it down to 1x, 1y. But now I've got to look and see if there are any negative exponents and whether or not I need to do something with them. If you look at the y, it has a negative 4. I know I can't have a negative exponent, so I'm going to have to flip it. Right now, again, like I said earlier, this is technically all over 1. So that negative 12 x to the 6 y to the negative 4 is realistically in your numerator. The negative 12 and the x to the 6 will stay in the numerator. The y to the negative 4 will actually go to the denominator. So my final answer is negative 12 x to the 6 divided by y to the 4th. Remember, when I flip that exponent, it changes it to a positive exponent. We'll go through 2 more. All right, so let's say that I've got 3x to the 7th, y to the 10, divided by 6x to the 4th, y to the 2nd, divided by, or not divided by, sorry, close my parenthesis, to the power of 3. All right, so that 3 on the outside of your parentheses, yes, that is raising it to a power. I like to simplify inside the parentheses first before I move that 3 to everything. That way I'm moving it to less items, hopefully. So I'm going to simplify, like I said, inside the parentheses. 3 over 6, that's my coefficients. That really actually goes down to 1/2. I'm just going to make this a big fraction. That way we know for sure where everything is at. With the x's, I have 7 over 4, so that's going to give me a 3. Now here's the trick. If you don't want to have to deal with the negatives, subtract your exponents, and whichever exponent is higher in terms of where you're starting, that's where the x is actually going to land. So because x to the 7th is larger than x to the 4th, I know that the x is going to be in the numerator because the 7 is larger than 4. Just a quick trick. 7 minus 4 gives me 3, so I've got x cubed. Same thing with the y's. I know y has to be in the top because that 10 is larger. And that would give me an 8. So right now the only thing in my denominator is that 2, but that's no big deal. That 3 is still out there, so now I'm going to actually apply that 3. And remember, it goes to everything. So this is now 1 cubed. Just do my x first. Not adding this time, I'm multiplying. X to the 9th, y to the 24th, 2 cubed. Okay, so the 1 cubed and the 2 cubed I can actually simplify myself. You can type that into your calculator if you need to. My final answer, 1 x to the 9th, y to the 24th, divided by 8. And last but not least, let's talk about scientific notation and how that might alter, your exponents. So for instance, let's say that I have 3.69 times 10 to the negative 5th times 4.1 times 10 to the 8th. So with this, your scientific notation is using exponents, and there are properties of this. So when we're looking at this, yes, you could just type this into a calculator, but you could also do some of this by hand. And the reason why I say that is because if you look at it, the tens technically are like your variable. So realistically, it's like saying this is your coefficient and this right here is your variable. Okay, so it's really not that big of a deal. So we would take 3.69 times 4.1, and that's times 10 to the third. The only thing that can change this, though, is when you do that multiplication of that 3.69 times 4.1, that might alter where your decimals actually go. So then you're going to have to change some stuff. Because this actually ends up being 15.129 times 10 to the third. And everyone knows in proper scientific notation, we can't have a number larger than 10. So that actually does change it a little bit because I got to move this. So I gain a 10. So just something to note. That scientific notation can use the properties of exponents. However, it is not the end-all be-all because your coefficients could change that final number. So that's something to make sure that that's in proper scientific notation.